I am proud to be able to present to you Mr. Daniel Peck from Barracuda with abusing web APIs through scripted Android applications.
Thank you. Make sure we're going the right direction with these buttons. All right. So first of all, thank you all for coming. I know it's rough getting out here on Thursday mornings a lot of times, so appreciate having a good full house here. Today we're going to talk about abusing web APIs through scripted Android applications. It's a turbo talk, so it's going to be quick, and we're going to do a very practical approach to things here. Giving you good groundwork to kind of dig through these Android applications and do a little bit of fun things with them. First, a little bit about me. I'm one of the principal researchers at Barracuda Labs, the research division of Barracuda Networks. Do a lot of work studying malicious messaging on email, social networks, IM. We also do a lot of data and trend analysis and general information security, both the industry side of things and also looking at, for example, how dangerous the web really is. We do a lot of stuff looking at very popular websites and seeing how often their ad networks are compromised, what the infection rate is, things like that. My Twitter handle's there for myself and for our team. Past lives, I did some offensive control system work for a while. It was a lot of fun. I wrote more snort rules than any man should. Done a lot of reversing through the years and, of course, assessment work. So very similar resume to a lot of you out there, I'm sure. The session outline, first we're going to start with target selection. We're going to look at the application specifically, look at the APIs a little bit and talk about our approach. We're going to talk about the foundation, stuff you need to know as you dig into this, and exploration of it. We're going to iterate between those two, both from looking at the binary, exploring it, and understanding it, and then the network level as well. And then we're going to talk about how to control it and have some fun with it. So we're going to do this in story form as well, because it makes it a lot more interesting. And it's very close to what I did when I kind of figured out this technique and wanted to share it with everybody. So we're sitting there last year when I didn't get to come with BlackHat for some fun having a baby reasons. Not myself, but so I was looking at social networks, and a lot of them have kind of got going and got a foothold and getting control of their spam problem. But if I wanted to start like that day or today and have, say, 100,000 spam accounts on Twitter, Facebook, Pinterest, whatever your hot new social network is, how would you get started? So you look at what's there and you kind of start going through it. So we're going to say our fictional one here is Twacebook that we're working through. So like most of them, they have a great web interface that you can do a lot of cool things with. They have a great API that's somewhat open to third parties and increasingly locked down. We'll talk about that a little bit as well. And we want to get a few thousand accounts, but there's some restrictions. You have things like CAPTCHAs if you start going through the web API and run your scripting through that. You don't want to deal with that. You have rate limits. Again, you don't want to deal with that. So we're trying to create a few 100,000 accounts. We don't have time to waste. We got to get that malware out now. So we'll start looking at this a little bit. Some good things we have on our side is, like we said, the API is already defined because they allow third parties to use it. It's just in a somewhat restricted fashion. A real positive we have is these social networking companies, like a lot of startups in Silicon Valley, are very worried about friction on their mobile apps. Nobody wants to take the time to enter a CAPTCHA or solve any sort of problem on their mobile device. So you don't have those restrictions in place. So that's our first clue. We can maybe look at using the mobile device or the mobile app to work through this, see what kind of APIs they call. We'll start with the assumption of creating our own client that mimics these calls that the mobile app is making and work from there. Some more assumptions. Well-documented API, we're going to assume they're probably using their same API. That's pretty standard these days, is if you've developed a robust third-party API, you're probably dogfooding that a lot internally as well, so we'll work on that assumption. It's probably going to use OAuth because that's kind of the new hotness, or the old hotness, depending on how you look at it. And a lot of these web companies are using it because, or these social networking and mass media companies are using it because they're very comfortable with it on the server-to-server web app kind of side. So they're also using it on their desktop and their mobile apps. And we're probably going to have to extract those keys to really have some fun with it. We're going to build on existing tools a lot. I took a class in college for artificial intelligence. which is a terrible class. Never take it. AI is boring as hell. It's all just graph traversal, and it's just mind-numbing. But the professor there drilled into our head a lot, do the dumb thing first. And that means use other people's tools. Do the simplest thing possible, because most of the time you can just get that problem out of the way and move on to the more serious things. So we're going to build on existing tools and use other people, much smarter than me in many cases, what they've done. So just the foundations, we're going to kind of run through this part quick. I've got links in the slides to all these tools so that you got a good baseline of tools to start working with. I'm not saying these are the best of breed tools by any means, but I've used them all and they've worked for my purposes. If you find something later on that works better for you, let me know. I'd love to know myself. So first thing we need to do is worry about intercepting these app communications. Something I found really good for that is ProxyDroid. It tends to run on most anything. And we're going to look at Android for this app, by the way. I didn't mention that specifically, but I didn't really want to get into iOS reversing because I've never really done that when I started down this road. I've done a small amount of Java reversing at the time. And I knew APKs had a lot to do with Java, very similar. So we went down the Android path with this. We're also going to have to intercept SSL because that's something to worry about, because honestly, if you're not having to intercept SSL with the apps you're trying to do these techniques with, you're going the much harder way. Because if they're not wrapping things at SSL, you can probably completely do anything you want anyway. That's just kind of the baseline these days. There's a million write-ups all over about how to add your own CA stuff to an Android device, but there's some quick basics there that we won't go through. Some gotchas to look out for if this is your first time playing with Android devices and certificate stores. Make sure you have the right bouncy castle version for your crypto stuff, because that breaks in very unexpected ways that are very hard to debug if you don't have that. So make sure you have it right. And procedures for doing this CA manipulation is much easier on the 4.0 devices if you can use one of those, but it's very doable on the 2.3 as well and up. We're going to also need to proxy and get in the middle of these things. If you're not using Burp for your proxying, you probably should. It's a great tool. We're going to use that some more later on in some of our things. The guys behind it are doing some awesome stuff. Does invisible proxying and generate certs on demand. When I initially did this, it didn't do this second point for me. But now it guesses based on the DNS request you've made. It generates a correct common name cert for the next SSL request. So you don't even have to tell it exactly what host name anymore. So Burp's awesome. Use it. Saves time, and it's very cheap for what it does. So getting down into it. This is our intercepted traffic. This is what we're looking at for these kind of things. You've seen our OAuth signatures. You're seeing a post. It's your kind of standard, HTTP API, right? And then all this API junk as well that we're going to talk about. So OAuth, as I said, this is kind of very popular in these kind of apps. I just show hands for anyone familiar with OAuth? Heard of it? Implemented it? A couple? All right. 1.0, 2.0? 1.0? 2? Okay. All right. So we're going to be talking about 1.0 here. 2.0 is kind of still in flux and kind of messy. Twacebook, our targeted company here, uses 1.0 still. It's a little bit simpler to wrap our heads around, but the approach is very similar. So for those of you who aren't familiar with OAuth, and there wasn't a whole lot of you, so we'll move quickly through this as well. It's essentially a way for clients to not, or for users to not expose their passwords to clients that they're using, which is a good thing and very useful. It goes through and it signs requests. Usually these days are done over SSL, but OAuth was designed so it didn't have to be. It could all be in clear text and it's just the HMAC sign. So your requests are in the clear, but it's cryptographically signed so you can verify that it's right. So you can verify that it came from the expected client and the pair of user token with that client. As I said, users don't have to give their password to third-party apps. Providers get to restrict the apps, but there's some negative things as well that come along with it because it's kind of a package. So you get this sort of client DRM thing going on with OAuth. We've seen that a lot, specifically with Twitter in the mainstream kind of technical world, that as they started cracking down on third-party apps a lot, their own first-party apps get certain permissions, and their OAuth keys work to do more things. Third-party apps have restrictions, like they can only have 100,000 users, They can't create new clients, etc. So you have this kind of DRM for app sort of world where you, as a user, have full permission to use the service, but your choice of apps is limited by this technology. It's designed to work very well for server to server. As I said, it was designed initially for that. For web app A to be able to talk to web app B, and there's no passwords exposed between the two. It's a good system for that because it's much easier to keep a single server, the keys on a single server, relatively secure. That's kind of what we base a lot of our work on in general. If you can't protect one server and the keys on it, we're not doing too well. But this same technology has been pushed down to the mobile apps and the desktop apps, which never really made a whole lot of sense to me because the keys are, of course, in the binary that you're downloading and running. So Facebook's own private keys are right there on your desktop. You just have to get it. So it's really only keeping kind of honest devs honest. And besides that, if I'm running arbitrary code on my systems, I don't care about exposing my passwords to it. I'm already running arbitrary code on the system. You can get a keylogger at that point. But anyway, digress. So we got that. We see that it's OAuth. We see what's going on in the network. I'm going to move on to key retrieval here. As I said, we're focusing on Android here. And when reversing these kind of apps, and Java in general, or JVM based, there's kind of two approaches you can use. And it's good to kind of do them both back and forth. It gives you a lot of info. You can go with disassembly or decompilation. So your straight up disassembly is going to usually produce something like Smalley, which is a bytecode similar to x86. It's very assembler-ish. You can also use Java decompilers, which produces Java code that's not compilable, but looks a lot like Java. And you can get a more high-level understanding. So these two work hand in hand very well. If you want to know what's really going on, you get down to the bytecode level, the assembly level. But if you want to have a good idea of the algorithm and kind of see it from a higher level as you're digging in, the decompilation works well. To understand why we're doing that, we're going to talk a little bit about Android. If you've ever been in a talk about Android, you've probably seen this slide or this image. So it's very, very simple. Most everything on your Android application or Android device runs on a Dalvik virtual machine, which is a Java virtual machine subset. It runs on, I can't remember the project code name, but from the Apache Foundation. Anyway, their JVM version. And Dalvik, or APKs that run on these Dalvik virtual machines are very similar to Java jar files. The only difference, or the only substantial difference, is that instead of jars, it produces a DEX file that's optimized for low memory, lower processing environments. Everything's deduped, compressed down a little bit, mostly just to save memory, like I said. But at the heart of it, it's very similar to your kind of standard JVM environment. So if you've ever done really any deep stuff in Java, you're going to be fairly familiar with what you're seeing. Just a little bit about Dalvik so that you understand a few of these slides that were coming up. We're by far not going to get down into a full tutorial on the assembly language here of Smalley, but we're going to get just a little bit of it. So Dalvik is a register-based machine. There's essentially an infinite number of registers because it's a virtual machine. So optimized for low memory environment, like I said. And it uses the Dalvik instruction set, which is similar but a subset. And the Smalley bytecode looks a lot like this. Again, if you've done much Java, this might look a little similar. And despite being a little cryptic here, Smalley is actually a real pleasure to reverse. Like as far as assembly, low-level languages like this, Smalley is very concise and very specific in what it does, and allows you to really wrap your head around it quickly and understand the full thing. So here you can see a class is being declared. It's a subset of the Java object class. This is defining a method constructor init. Got a couple locals. So you have these P0, V1, V0, V1. These are registers. P registers are parameters that are passed in. V are virtual registers that you're using within it. The last X number of registers, depending on the parameters passed in, are overlaid on the last V parameters. Might not ever be exposed to that, but something to look out for if you're ever doing this. It's a 32-bit machine for almost all the registers. 2 are 64-bit values, the long and the double. So when figuring out how many parameters are being passed in to various functions, keep in mind on that those are going to occupy 2 registers if it's a long or a double. These are the, looks like everything's not quite on the screen. There we go. These are the primitives we're looking at. These are the kinds that you have access to from the Smalley deep level. Void, Boolean, byte, short, etc. And then your L's are your objects, your higher level Java objects that are defined. They're available within the assembly as well. And you're going to see that. And we get to make use of that in a lot of interesting ways because we know what these objects are defined as, what they're called, and that's what makes Java work. Once again, the wrong way. There we go. So, little function declaration to look at to kind of get your feet wet and understand what we're looking at. It's defining a method. It's private, static. It's named A. It's the name of the method. It's the type. You can see it takes in 5 parameters, or 6 parameters, 0 through 5. So it takes in a HTTP request base. It takes in a class AA. It takes in a long. It takes in two strings and it returns a string. Everybody see that? It's pretty simple. Good to go. I keep hitting the wrong button. It's backwards. Opcode's very similar to what you'd see in a lot of assembly languages. Opcodes move the result of the last function to this virtual register. Return object, so return from the function, return this object or this register value. Invoke, it's basically calling methods a lot of ways. There's a ton more of these we're not going to go into because that's not the right kind of talk for this. But again, there's a great reference there that you should look at if you're interested. So getting back to the app and what we're really trying to do. So we're focused in on getting these keys. So like any good reverser, we're going to start doing the dumb thing first. We're going to be grepping for strings. We know that these are signed with HMAC SHA-1, so that's a pretty good thing to look for. And we start digging through this Smalley output code that we have, our disassembly, and we start finding strings that are related to what we want. We see some UTF-8, we see HMAC SHA-1, so that's cool. Of course, there's a lot more to it than this, but you dig through and you find the functions you're looking for. So we have a pretty good idea of what's going on there. And back and forth here, this is the difference between the decompilation and the disassembly. So this is the decompilation. You can see this is very, very Java-like, what's created by JD GUI and very similar tools. So you see the output here, it's almost reads exactly like Java code. It's not necessarily compilable, but it looks very similar. Think of it as Java pseudocode. Whereas the Smalley, the same thing, it's a little bit more low level. You see exactly what's going on, exactly what parameters are put in, what register values, and so forth. So even if looking at that, say you didn't have a great idea what's going on, the good thing is people who write Java don't really like to get outside the box too much. So if you're looking for things like crypto or whatever, search Stack Overflow and you'll basically find identical code to whatever you're going to find in any Java app. Because people don't get too far, which is good because you shouldn't do your own crypto. But finding little snippets like that really give you an understanding to be able to look at this is what the Java code is, this is what the disassembled code is, and this is what the Smalley. And it'll let you iterate back and forth and really get that in your head well. So, again, looking at this, we see what we want to get is that key that's passed into the HMAC function. So that's the OAuth key that's being used to sign stuff, to do that HMAC SHA-1. Okay? So the good thing, sorry, backwards again. Doing the dumb thing first. We can turn to every freshman year computer science major's best friend and do printf debugging. With Smalley, you can edit the assembly and rebuild the Android application and run it again. So we can just dump in debug statements right into this signing function, and then our keys are dumped out into the log. This is why you see in the Android App Store Angry Birds Pink, Angry Birds Thai version that aren't made by Rovio. They're made by third parties that have ripped apart the APK, done what little edits they want to change the color, change the language, maybe make it Angry Rats instead of Angry Birds, and then rebuild it under their own. Examining the logs, we got our secret key. Rock on. So this is very kind of manual way, but it lets you get there. So now we can write using the third-party API that's already been defined by our target Twacebook. We can use that key, sign a process, and move on, right? Well, wrong, because a couple of things. First of all, we get invalid signature in this specific case of what I was trying to do, but also, in general, most of us are kind of terrible at writing code. We're a lot of cowboy coders in the security hacker world. So it's good not to do code if you don't have to, especially when you're re-implementing other people's methods, because you don't know if it's your bugs you're finding or their bugs that you're finding when you're trying to access these things. I think we've all probably been in very similar situations and then eventually beat our head against a wall enough that we realize we did something stupid and cost days of work. So in this case, for our example, the Twacebook devs have been especially sneaky. And they're not just using the HMAC SHA-1, they're also doing their own little crypto routine of hashing it before they're passing their key in. So that key doesn't work anymore. And we get this ugly hash algorithm that we found. Looking at the Smalley, it's about 30 pages of this hell. So hashing algorithms, if you've ever dealt with them, are just insane. Looking at them from an assembly level sucks. You're not going to be able to get much of an understanding. This is going to be almost impossible to re-implement, or at least take a very significant amount of time. Something that most of the time you're not looking for when you're trying to, reverse an app to get access to the API. So here's where the fun really begins. I sat down and started thinking about, wouldn't it be great if I could just use the code that's already in this APK? If it's already there, I just have to be able to call it in ways I want to do it. So the last few years in the kind of programming environment world have led to some really cool things of JVM-based languages. Python was one of the first ones. JRuby's come along very nicely. That's my personal choice and what we're going to use for the rest of this example. Clojure, Scala. More and more it's turning out that Java is a worst case implementation of using the JVM. A lot of things not to do. But the JVM itself is a fantastic, amazing platform. Some of the smartest computer scientists in the world have been working on it for a long time. So you get amazing performance, runs anywhere, and when you're working in these kind of languages that are JVM based, you have access to pretty much all the Java libraries out there, which probably a lot of us don't think about because we're not, at least I'm not, and most of the security types I know aren't really Java programmers. That tends to be more of an enterprise kind of programming environment. Some academics tend to use it. But the libraries comparing, say, to like Ruby gems that are available versus Java libraries, it's like magnitudes difference. Like there's Java libraries for anything in the world that you need to do. So having access to these is awesome. And what we learned previously is that APKs and the DEX files within them and jar files are very similar. And you can convert between the two of them. So using these JVM languages, specifically JRuby here, you can pull out the DEX file from it, change it to a jar file with using DEX to jar, another one of these tools that's commonly available and is included with APK tool and some others that we've linked to. And then we can just call it. So we don't have to worry about what the code does anymore. We've just loaded it up into our JVM instance within our JRuby runtime here. Import the class, and now we can just use it however we want. We just have to know the right parameters to pass in. So this is happy times. We can now just write whatever we want. Treat the APK and any APK as a library function. You can iterate up. So what we just showed was, this is very simple, like the obfuscator looks like that we were talking about, that we were trying to get by the little crypto. You just pull it out and call it with the byte array, and then you're getting out what you want, and you can go along your merry way. But the more you get into understanding, you can iterate up. And everyone who contributed to the tools mentioned. This was a lot of building on existing tools and kind of gluing together the cool bits that I don't think we do enough. We tend to reinvent the wheel quite a bit. So I like building on other tools. And thank you all very much. Any questions?
Are there limitations to converting jars to DEX files?
There are. The question is, are there limitations to converting jars to DEX files? Usually you do it the other way, is DEX to jar, when you're going from Android, to kind of standard Java world. There's some bugs here and there, but for the most part, it's pretty clean going apart, especially going between the different implementations where, like I said, Dalvik is based on the Apache Foundation's JVM implementation, whereas you could be using the Open JVM or the Sun JVM or JRE or whatever as well. So there could be some bugs pop up, but really I haven't had any problems with the stuff I've been doing with this. But again, we've kept it on a pretty high level of just trying to call the highest level APIs available within these APKs and go from there. Yes? So the question of, I couldn't hear it that well, but have I had any problems with doing DEX to jar on obfuscated bits?
Yeah, so that it comes back and saying that I can't, and it gives you Smalley in the results. Have you had that issue?
So Smalley is always going to be able to build right back, especially in an obfuscated way. And then going from the DEX to jar, I haven't personally found any problems with that. I won't say that there's none out there, but I haven't found a problem. The Twacebook example here we worked through was all completely obfuscated code. All the classes were AA, lowercase c, etc. So it was all just working through the strings within the invariant strings. Yes? And the question was, the secret key that was shown, was that the app secret key or the user secret key? Sorry, I wasn't more clear on that. That was the app secret key. That is what was used to sign the request to say, I am from the official Twacebook app. This request to create a new user is coming from a valid place, which means that you don't have to ask a CAPTCHA, you don't have to do any sort of rate limiting in this case. And that's what we were able to get around by using that. So then we can completely impersonate that client as our third-party code with whatever we want. Maybe time for one more, or are we done? Okay, we got to cut. So thank y'all all very much. I'll be outside if you have any more questions. Thank you.